My topic is heat exchanger. First of all, we will see the contents of this topic: introduction of area of research, heat exchanger, applications of heat exchangers, principles of heat exchangers, literature review, research gap, objective, tentative title of the thesis. Now, first of all, we will know about the introduction of heat exchanger. In a heat exchanger, heat energy is transferred from one body or fluid stream to another. Basically, heat exchanger transfers heat from one body to another body or from one fluid to another fluid. A heat exchanger is a device that is used to transfer thermal energy between two or more fluids, between a solid surface and a fluid, or between solid particulates and a fluid at different temperatures and in thermal contact. In the design of a heat exchanger equipment, heat transfer equations are applied to calculate this transfer of energy so as to carry it out efficiently and under controlled conditions. Now we can see the figure of heat exchanger, and its parts name is the tube outlet, tube inlet, shell outlet and shell inlet, and baffles. Next point is the applications of heat exchangers. In this topic we will see what are the applications of heat exchangers. First one is the heat exchangers are used in industry for heat transfer. The closed type heat exchanger is the most popular one. One example of this type is the double pipe heat exchanger. In double pipe heat exchanger, the hot and cold fluid streams do not come into direct contact with each other. They are separated by a tube wall or flat plate. Heat exchangers prevent car engine overheating and increase efficiency. Next, we will see what are the principles of heat exchangers. Heat exchangers basically work because heat naturally flows from higher temperature to lower temperatures. Therefore, if a hot fluid and a cold fluid are separated by a heat conducting surface, heat can be transferred from the hot fluid to the cold fluid. This is the literature survey about heat exchanger. Next one is the research gap. First point is the limited research on bio-inspired or 3D printed insert geometries, lack of multivariable optimization for performance across varying Reynolds numbers, fluids or temperature ranges. Next point is the limited understanding of how the thermal properties of insert materials affect heat transfer and pressure drop. Lack of data on insert impact on fouling, cleaning and lifespan of heat exchanger. And last one is the limited attention to life cycle analysis or sustainable materials for inserts. Now we will see what is the objective of this topic. Based on research gap, the objective of the present work is to investigate the impact of various insert geometries, for example twisted tape, helical coil, vortex generators, on the thermal performance of a double pipe heat exchanger. Next one is to enhance the heat transfer rate in a double pipe heat exchanger while maintaining acceptable pressure drop and pumping power requirements. To develop and validate numerical models, for example safety simulations for predicting flow and thermal behavior with inserts. And last one is to analyze the effect of insert materials, metallic versus non-metallic, on heat transfer performance and thermal conducting impact. Now we will see what is the tentative title of the thesis: enhancement of heat transfer in double pipe heat exchangers using twisted tape and helical inserts.